Leo, you can share your screen.
Yes. So I did that. I printed the temp as well. And the first time around, it did print the data. Second time out, it printed null.
Okay, so it means that there is after we pop up something in the first it worked, but the second time it doesn't work because, like you said, you already know that our pointer is not updated, right?
Yes.
Okay, so how we are able to catch out the information that is being returned from the pop method? So that is something that we need to think about. So you know very well that if you want to record the information that you catch out from a function or a method that is being created, you have to use a variable of the same return data type. So when you return it from push an integer, you put it here, you assign it to a top, which is also an integer. Pop return an item, which is an object. So you would like also to create something, a kind of same data type to catch the data from the pop. If you put a string, it will give you an error because you are returning an object. I know this is could be new to you. I think you didn't deal with that before.
Then would I have to make a new like item object here as well then
Yes,
within here?
yes. You can put it on top. You can put it at the bottom. It doesn't matter. So I wouldn't wait. I would like you to know something. When you use new, you're actually calling the constructor, but you didn't put a constructor with empty brackets here. So I would say just put define the item and put null first, and then here let it get the object that is coming out from pop. Yes. So we're still getting a problem, right?
Yes.
But why? Even though we managed to catch the information that is coming out through assigning it to item. But my question to you now, uh, top here is still 1. Even though here inside your pop, it becomes 0. So it means here in this code, calling code, the top is not updated. Although item, if you try to print inside item, you will find that the pointer is actually become 0. So now, do you have any get method? Do you know what's the meaning getter methods of a
Yes.
class? So
Yeah.
can you create a getter method inside that class to be able to extract information out of the class? So we need to make a getter method for data and for the top pointer. So you can say get data and another one, get pointer. Good, good. Excellent. So now you have getter methods. So I want you to use that getter methods after you assign whatever you returned to item. So item now contain an updated information for us. We would like to use the getter method to see the data and the pointer. You can initially make a print statement and then write item.get data and write item. Excellent. I couldn't see the information that you managed to
As
print.
this.
Yes, Alice and 0. Okay, so it means that we managed to get them out here, right? So,
yes.
but still the pointer is 1. Why is that? We only be aware, just we only printed that, but we never assigned any variables to that. So get pointer, or the pointer here, the updated pointer value is there, and we are able to retrieve it. But did we put it to any variable that should be updated? We always update the top pointer right here.
Yes.
So how can we do that?
Well, I mean, the easiest way to would just be to go like top equals get pointer, but I don't think that would be like a good solution.
Can you repeat again, please? I didn't get you.
Oh, so what I was saying was, the easiest way to like fix the top pointer in this case would probably just to go like top equals item dot get pointer, but I don't think that would be a very good solution.
Why you think like that? Can you try it first and then judge after that? So what do you think now? So you managed to pop up Alice at the start. So we have Alice and Julie. You managed to pop up Alice, and you managed to pop up Julie. And when you printed, it seems that your stack is empty.
Yep.
So does this mean that it's working fine?
I mean, I guess it does work, but it doesn't like feel like a good solution.
Okay, tell me, what do you think? What could be done?
Uh, well, like I'm not exactly sure. It's just that like just the idea of like creating like a, what do I say, like having to like change top as well every time just like feels inefficient, I guess.
Yes, I agree with you that yes, it looks like it's not so tight, yes, and it can be flowed anytime, yes, I understand that. But that's how the static implementation for a stack works. That's why
Oh,
they created a dynamic stack, so that they take care of that dirty business for you and hide it from you. But actually, this is how it should work in the world of a static stack. It's not, yes, I have to agree with you. It's not perfect, but okay, that's the only way that you can keep track of top. There is no other way. You have to always return the top. Always have to return the top because it's always decreased and increased by your operation, either through pop and push. If you come up with a different solution, okay, I'm willing to listen. Um, and I trust that you are smart because I noticed that, and also I think you if you open the slides, the ideal solution that is there in the books, you always manage to create sometimes different solutions. Same like when you created the break yesterday. If you look at the break that you created, it's a smart solution. It's a smart thing from you. And the ideal solutions that comes in the books is slightly different. But I have to agree with you. Yours is it's working, and as long as it's working, it's fine. So if you, I will not say that, oh, please stop. You cannot think beyond the book, because no, I mean, why not? You are smart and you're capable of that, so I'm willing to listen. And you can, if you want to try and think about something, just tell it to me next time. So I wouldn't stop you. Um, just what I would say is that I agree with you. This is not a perfect way, but that's how it works and the best standard solution at the moment. And this is how the books say it. Okay.
Yes.
Okay, perfect. So should we continue, or you would like to ask anything
Yeah.
here?
Yeah, we can continue.
Okay, stop your share and let me share with you what should we do next. So, Leo, we already created the pop, and remaining for us the peak. And this is so we have to write a peak. You know, the peak is similar to the pop, except that it doesn't really remove the item on the top, right? You already remember
Yes.
that? Okay.
Yes.
So we will take that and we will look also at if we want to create a loop like that, a for loop like that. Inside the for loop, I would like you to pop up all the items in the array. But in this case, I would request you to make the maximum size of the array to be 3, and to push one more item inside the array. So now you're pushing 2 items, right? So add another name, for example, pop. And so I make the maximum size equals 3, and then create whatever inside here to be able to pop up all the items. So this is slightly similar to the pop function, except that you have to deal with objects. You have to deal with the item object. Every time you pop, you have to do something here and print out whatever was popped out and see how it works here. So just here you are needed to implement that and pop up all the items. So I want you to think about that. So you will do that popping up again with the peak. Okay.
Yes.
Can you do that?
Yeah.
Okay, I will send you the 2 slides. This slide here. This slide here. But just let me understand from you. Peak should return what?
Pick the data.
Okay. So when you picked out something, what did you see at the end?
Also, the peak would be this one, I think, because the one beforehand was the last push.
So the peak is supposed to return a data, but I didn't see you catching that data in any variable. It's supposed the peak should return a string. Okay. If you run now, yes, your data is stored inside the data variable, but you haven't printed out, so we can never know what actually is inside the data. You only printed the stack, but you didn't print. Yes, perfect.
Yeah, so it printed here.
Okay, good. So excellent. Actually, that's great. It's really great. And I see your implementation here. It's I can't comment. It's excellent. You managed to get that. This is the trick, and you managed to get that perfectly. Yes, that should be fine. So yes, you ended up with all empty stack, right?
Yes.
Okay, that's good. Okay, it's done. You managed to do it very fast. It's good. Okay, so let me share. Let me do the share. So tell me, what do you know about the queues?
Queues is just like a first in structure, right?
Yes. So it is.
Or is it like a last in, last out, or
so
last in, first out?
So yes, I would say, okay. So yes, we have. So the queue is, imagine yourself standing out in front of a queue to buy some food, for example, or even to want to get out a passport from the immigration. So you go in queue. So the first person who come in is the first person who enter the immigration office. So I would say this is how it really works. So this is the first, second. So everyone that is being added to the queue is added at the end of the queue, and the first one that comes is the first one who enters the office. So I would say make it in your mind like that. So you can be waiting for food. You can wait. You can be waiting for your turn. You can be renewing your driving license. The first one who comes is the first one who enters the office. And uh, when the queue is top up, so people come and stand at the back. So, and also another example of that. So this is maybe a driving license queue. And we can also have another example, which is if you are printing a document and you have a network printer, and you and your colleagues are printing one after another. If you send your print document to the network printer first, so that is the first papers that will be printed out. Your colleagues papers will be printed after you, and it depends on the time that they press the print button. So the first one who send the paper to the printer, his paper will come out first. So I think this is the best way to describe how the queue and the stack works. So in the stack, the last in, first out. But here, first in, first out. So how we think about it, as we said, the stack is like a stack of plates that you wash the plates and then you stack them on top of each other. So this is an example of a stack plates, okay? And a queue, you can be waiting to apply for your driving license or renew your driving license, and then you take a queue, you take a number, and then the first person who comes is the first person who go to the counter and start renewing his driving license. Does this make sense to you?
Yes.
Okay. Will it stick in your mind like that? Because I know in your age, they never actually. I mean, when I was in your age, they never explain and give a real example in real life. So they say LIFO and FIFO, okay, but they never explain something in real life that we can really stick in the mind. So as I said here, as you can see, so we have two things actually to keep track of the queue. Last time in the stack, we only have the top pointer because it was something like that, and the top pointer, this is the stack. So the top pointer is the one who really takes care of whatever in top. So there is nothing coming out from here. Whatever comes out, it comes either enter here or come out from the same place. So it's like a closed container. But in the queue, no, the queue is here is being emptied out, people go out from here, and the new people is coming out. New people is come out from the end of the queue. So it's like, so it means that we need to take care of the start of the queue and the end of the queue. We need to really mark that. So if somebody go in to the counter to renew his driving license, means that his places become empty. So we need somehow our pointer to be pointing to the next person. So when they call a number on the screen asking the people, the first person here, to go to the counter, and then they will, next time they call, they have to call the next number or the next person in a queue. So it means that we have to take care of two things, and not like the first stack, we only take care of one pointer. Here we have two pointers, a top pointer and a rear pointer. So the rear pointer takes care if somebody is added to the queue, then our queue is no longer pointing here. It will have to point to the next space that people can use it to enter our queue. Does this make sense to you?
Yes.
Okay, so we have here a linear queue and we have a circular queue. Okay, so let's see how it goes with the implementation. So like I said to you, so this is, assume this is a queue. We have a front pointer and a rear pointer. And they will be, once there is an item here, they will be pointing to the same item. And have a look here. So we added pop to the queue, and our rear pointer is always pointing to the end, towards the end, and the front pointer. So we're talking here about programming side here. So this is our front pointer. Our front pointer will always be pointing here, and the rear pointer, whenever something is being inserted, it will be always pointing to it. But what if we said that we want to dequeue an item? So here in queue means that we are adding to the queue. Dequeue means that we are taking something out. So we are not taking something out from the end like the stack. We are taking out from the front of the queue. So because Anil is the first person who come to the queue, so he deserves actually to be the one the first served. If you come to the queue early, it means you deserve to be served first. So it means that our front pointer will be pointing here. Our front pointer will be pointing here to the next item after the first item being dequeued out. Okay.
Yes.
Okay. Does it make sense so far?
Yes.
Okay. Good. So this is how we initialize our linear queue. So okay, the first thing that we have, okay, we really need to close and open again.